Why earthquake happened? In today's video we discussing about earthquake. Welcome to Hayatullah World. Before going to the video, please subscribe my channel. Earthquake are the result of sudden movement along faults within the earth. The movement releases stored up elastic strain energy in the form of seismic waves, which propagate through the earth and cause the ground surface to shake. Such movement on the faults is generally a response to long-term deformation and the buildup of stress. The structure of Earth. Seismic waves from large earthquake pass through the earth. These waves contain vital information about the internal structure of the earth. As seismic waves pass through the earth, they are refractio, or bent-like. Rays of light bend when they pass through a glass prism, because the speed of seismic waves depends on density. We can use the wave time of seismic waves to map change in density with depth and show that the earth is composed of several layers. The most outer layer is called mantle, the second layer is called outer core, the third layer is called inner core. The earth's outermost layer is fragmented into about 15 major slabs called tectonic plates. These slabs form the lithosphere, which is composed of the mantle. Tectonic plates move very slowly relative to each other, typically a few centimeters per year. Observations show that most earthquakes are associated with tectonic plate boundaries, and the theory of plate tectonics be used to provide a simplified explanation of the global distribution of earthquakes. What drives the movement of tectonic plates? Below the tectonic plates lies the Earth's asthenosphere. The asthenosphere behaves like a fluid over very long time scales. Three of the forces that have been proposed as the main drivers of tectonic plate movement are: Number 1, mantle convection currents. Warm mantle currents drive and carry plates of lithosphere along a light conveyor belt. Number 2, ridge push buoyant upwarding mantle at mid-ocean ridges. Newly formed plates at oceanic ridges are warm, so they have a higher elevation at the oceanic ridge than the colder, more dense plate mantle farther away. Number 3, slab pull. Older, colder plates sink at subduction zone because, as they become more dense than the underlying mantle, and the cooler, sinking plate pulls the rest of the warmer plate along behind it. Types of plate boundary. Number 1, divergent plates moving apart. Number 2, convergent plates coming together. Number 3, transform plates moving past each other. Elastic rebound theory. Elastic rebound theory was originally proposed after the Great San Francisco earthquake in 1906 by the geologist Henry Fielding Reid to explain the deformation caused by earthquake. Before an earthquake, the buildup of stress in the rocks on either side of fault results in gradual deformation. Eventually, this deformation exceeds the frictional force holding the rocks together, and sudden slips occurs along the fault. The releases the accumulated stress, and the rocks on either side of the fault return to their original shape. Elastic rebound, but effect on either side of fault. During an earthquake, the rock on side of the fault suddenly slips with respect to the other. The fault surface can be horizontal or vertical or some arbitrary angle in between. Faults are classified using the angle of the fault with respect to the surface known as the dip and direction of slip along the fault. Faults that move along the direction of the dip plan are called dip-slip faults, while strict slip faults are classified as either right lateral or left lateral. Faults which show both slip motion are known as oblique slip faults.